Let me go back a slide. Yeah, my name is Tywin Kelly. I'm an artist based in Seattle, Washington. Uh, I've long had an interest in photography and film. I studied film and media studies in my undergrad, but in parallel, had this sort of separate interest in computers and playing in computers. And only recently, I've started to like converge the two together and play with them. So this is an example of an art piece, which I'll explain more later, sort of like a teaser. I want to do some other stuff first. But yeah, today I want to talk about computational photography and my past 6 months investigating, researching, and experimenting using art on this topic. So I think, yeah, just give a rundown. I'll give some examples what computational photography even is, just so we're on the same page. And then I'll jump into some experiments that I conducted to help my understanding. I'll walk through my thought process there. And finally, I have these like theses that I iterated throughout my experiments that I want to like enumerate and expand on and show like how they progressed through each other. And hopefully you'll come away with an understanding of computational photography and what it is. So this is my cheap, sort of cheeky definition of computational photography. Um, in my idea, computational photography is all about how an image is processed. And if during that processing of the image, the software out influences the optics, then that for me defines computational photography. So if you take an image with like a DSLR or just a point and shoot digital camera, that for me is not really computational photography because those cameras are designed to sort of emulate their analog film counterparts. The film CMOS CCD sensors are really just sort of to emulate 35 millimeter film and just turn noise into a signal, right? So what is computational photography? This is a diagram that I've made. And for me, these are the 5 pillars of the types of computational photography out there. You can think of it like a flavor chart, kind of. So I'll run through all of these really quickly and give examples of each. So this first one I call a time mosaic. And it's really any image process that takes it as an input, images taken over time. So if you ever use night mode, excuse me, on one of the newer smartphones, iPhone, Android, I think they all have them. What's essentially happening is you're taking multiple images over time, varying exposure, and what you're doing is you're aligning them afterwards, compositing them, picking parts of the image that are sharp or brighter than others, and layering them so that you have the least amount of noise. And what you get is sort of hyperreal, high dynamic range image derived from a kind of long exposure or smart long exposure. So that's an example of a time image, or sorry, time mosaic. And the counterpart to that is a space mosaic. So instead of taking through time, you're actually taking images across space. This technique is called photogrammetry that I'm showing here. And you basically take your own database of images in consecutive order and such that the images sort of overlap. And photogrammetry software can look at the similarities between two images and triangulate the parallax. In a sense, they can infer depth between two images as long as they're similar enough. And what you basically get is a 3D model by just taking flat 2D images. It was kind of a magical process. And since I'm actually going to talk about this more, I'll throw these examples out there. Of course, photogrammetry today is used in film, in Hollywood, and in video games as to create like hyper-realistic assets. But it's also used in business, agriculture, construction, landscaping, as well as in the medical field. So here, example of like scanning someone's mouth to get like a proper denture fitting, right? So it's definitely out there and being used. Another pillar is extrasensory. So a lot of computational photography takes or uses hardware that operates at a wavelength that we can't normally see. So tomography scans, or on this bottom on the left, is a point cloud generated from like a LiDAR or time of flight sensor on a self-driving car. And on the bottom right, we have like thermal imaging captured from drones, which is very useful for farmers to understand how their crops are doing. Another pillar is generative. And this for me just means purely computer generated imagery. So I like to provide this example. This cover of the IKEA catalog is actually not a photograph. It is completely 3D rendered. And actually 75% of the catalog is not made of traditional photographs. As you might imagine, they are 3D rendering, mostly because it's cheaper, easier to manipulate, etc. But And another example of generative is like sort of generative adversarial networks where you can create these realistic images from a data set that just and make completely brand new images. So these are faces of people that do not exist from this website. I thought was kind of clever. The last pillar is semantic, and this is really about the relationship between image and label. So, actually in the example that Suyasha showed, that would definitely fit into the semantic pillar, right? Because it's taking an image and posing it and labeling the person. And so here I have the segmentation, which is defining the outline of an object. And then we have like emotion detection, and all this, of course, relies on large databases and run through a machine learning algorithm and convolutional neural networks. So that was a fire hose of stuff, right? And that's sort of the point. It's because computational photography is everywhere and all around us. And this is sort of the feeling that I had. And this is my first sort of epiphany and thesis is that, wow, it's just all around me. It exists at every scale, and it's on our phones, it's in institutions, it's in science, it's in the commercial space. And so this is the feeling I was coming away with. This is a still from Mr. Bean, which is one of my favorite TV shows. But what we can see is that he's covered his whole apartment in newspapers. And for me, that was kind of like a symbolic metaphor for the way media, and in particular computational photography media, is just covering every surface. It's on our screens, it's in print media, it's like in the air. And this is like something that I just feel and I want to investigate more. So this idea was the impetus of my first experiment. And so this is a AR filter for Instagram, and is titled Behind the Scenes. It basically takes all that jargon I was throwing at you earlier and that I researched about these computational photography concepts, algorithms, processes, and places on the face of the participant. So in a sense, they are wearing the concepts that make this face tracking thing possible in the first place. So that was a kind of an act in like exposing and revealing this sort of Mr. Bean world to the participant. But for me, that didn't quite get to the idea that computational photography is everywhere. And so I kept on iterating. It's like, no, computational photography is somewhere. And that's when I decided to travel. And since I'm in the Pacific Northwest, there are lots of data centers out here, namely along the Columbia Gorge. There's a lot of cheap electricity and I'm sure some tax incentives. But I did like a couple day road trip and went out to like here you see the Google data center, Microsoft. I think this is the Intuit data center, Amazon, Apple, Facebook, all the large companies. And there's this sort of composition where I place my tripod in front of graphically below the data center, and as if the data center had kicked off, usurped the camera, where the spot of the traditional camera, in a sense, taking its place. And I was doing a lot of reading at the time, where like I learned we upload about 500 million images to social media platforms every single day, which doesn't include like the derivative images like proxy files, thumbnails, temporary files, other metadata, like 500 million images a day. And that sort of massive scale, I think I was trying to capture. I was inspired by artists like Evan Roth and Trevor Palin and Jenny Odell, who actually I learned about through some gray area people. And so I was pretty happy with this project, but I still wasn't fully engaged with it because I felt there's just analytical distance with the subject. I was just kind of taking photos of data centers and not really engaging with it. So I went back and I started reading some critical studies about media studies in general, images, cinema, screen studies, digital worlds, and post lens photography. And I started for myself to really flesh out this notion that, okay, for computational photography isn't just made up of technical stuff. There's like almost like a politics to it, where it has like social political implications, and it has like a landscape of its own. And I started making this sort of diagram, which I won't really explain. It's a little unreadable, but the way that images have a class within themselves and interact with each other really inspired me and to iterate on my next thesis, which was that computational photography has a mass. So as I was thinking about photography more as this thing with depth, I kept on coming to this idea of it has having a mass, meaning it has a weight in our lives, and also connotes a thing that's distant but also very close. So, for instance, if the Earth is a massive object, but we still have a intimate relationship with it, even though we don't know every part of it. We haven't been to every square inch of the Earth, but we still feel very close to it. And that's what I felt like I was getting to with computational photography, is like this Earth-sized thing, which I was close to, but and it had like this gravity, this mass, but I just didn't quite fully understand. And so around the same time, I was playing with photogrammetry, which is what I mentioned earlier, and I saw like I almost had like a moment again, like I saw this as a literal manifestation of what mass means, and stuff having weight. So this I was out on a hike in, I think, Eastern Oregon, backpacking trip, and someone had a drone and I asked to scan the mountain. I think we were in the Oahe Canyon. And I took these images back. It was a bit like also reminiscent of being in a dark room. I took the images there. I couldn't see the final outcome until I went back to my computer and processed them. And so I really felt like I was working with my hands. And then I started taking photos of my friends. And early on, I had some glitches and some aberrations, which I really actually enjoyed, and I left them in. And I enjoyed the artifacts of this sort of disintegration. And this is what really kept me going. And I was experimenting more. And then at some point I started merging them together and making these sort of collages of photogrammetry. And this for me was also another breakthrough moment as I started to make these larger dioramas, recombinant dioramas, I guess I would call them, and just merging disparate objects together where they weren't supposed to be mixed. And for me, this is like I suddenly felt like I was creating worlds, and this is actually what they do with a lot of video game creation and film creation. They capture assets in the real world, bring them in, and recombine them in different ways. And so I felt like I was doing this act of worlding as I read this artist Ian Chung. He has this term called worlding, and I really liked worlding as a verb. And so that's at that moment that's what I was thinking about. And concurrently, I read this thing by Sean Cubitt, and he writes about the mass image in this essay, and he had these ideas of all these images basically coming together. In my mind, they're like an image singularity, which I think for him, he's not quite being a doomsayer, but just sort of like wary of this massing of information and power into this we call the one interconnected artifice, which I thought was kind of poetic. So I wasn't quite at that level where I was scared of it, but I was very interested in this. I guess people nowadays would call it like a metaverse. But that for me was what kept my interest going. And then at some point, I sort of like had this declaration. It's like, okay, we are almost as images in this landscape. I'm in this world with these images, living with them, just as Mr. Beans with his like newspaper covered room. So like I think it's time to like learn how to like really communicate and understand these images. And that's sort of become the through line of my work, is this idea of media literacy and understanding the processing of images. And to do that, I started painting on them. So this is basically a photogrammetry scan of these two houses in Seattle. And I'll show you the process behind the scenes of what I'm doing. What I do is I take the scan, export the scan into this program called Adobe Medium, where I import it and I can actually paint in 3D or sculpt it in 3D. And I'm basically just drawing upon the surface of these objects. And you can see when you import, you get these other cool artifacts, which I clean up later. But this whole process for me was like this merging of myself painting and this automated process. So I ended up calling this series Centaurs, which is about the story of like, the chess grandmaster who was beat by an AI, IBM Deep Blue, I think, and came back and decided to create his own chess league where you can compete alongside your own supercomputer. And to this day, the Centaur pairing they call it centaur pairing between a human and a computer is still the most powerful or undefeated chess grandmaster. So that was my idea. It's like pairing myself, me as an image into this other image by painting on it. And so I'll just run through a couple examples of these. I like to do buildings. I like to do like natural scenes. Yeah, let's see. Yeah, and this one, I really like the way that the motorcycle turned out and how this thing sort of rests underneath. Yeah, this is a pretty recent one too. So I'm continuing to iterate on this. And as I said, the through line is image literacy. And as I play with these images in space, I feel like I become more literate in the sense that not only do I know the technical side of it, but you come to know it quite intimately. And so there's these two quotes from two media theorists. One is Douglas Rushkoff, programmer be programmed, which is pretty straightforward. If you don't know what's happening to you, then you sort of are under the control of some greater thing. So in this sense, if you don't know the algorithm that's controlling you, then the algorithm will just control you even more. And this second quote is from Jerry Lanier, who actually coined the term virtual reality back in, I think, the 70s, or maybe it was 90s, somewhere around there. But even though this is related to VR, I think it still applies to like all media and image making. And he talked about, he was asked in an interview what he thinks about VR, and it's like future and getting smaller and lighter, more accessible. And he actually had this funny counterpoint. He says, I think they should be ugly and a little awkward. And his idea was behind that is that you shouldn't be able to know the difference between reality and virtual reality. That a dangerous virtual reality headset is an invisible one where you can't differentiate between realities. And that's sort of my impetus for leaving in some of these glitches so you can tell what is real and what isn't, like what is the machine automation and what is the hand drawn, even though they both sort of blend together in a nice new way. I think there's a clear distinction, which I like to explore. So that is that series. My next steps are making these things IRL in real life. I've done a few things with 3D printing, so making these movies extruding these films. These are Edward Muybridge photographs from the 1800s, extruded a 3D model, and then I 3D print it, and then I painted this metallic paint. And then this is another series I'm working on, which is I call it mitosis. It's like I'm scanning these cameras and 3D printing these digital twins and placing them next to each other as a sort of like structural diptych to just compare, like, oh, here's this digital mirror or digital shadow of these objects. So yeah, that's my current thing, is trying to bring these not so ephemeral ideas of computational photography into the real world where they have literal mass. So that is my talk, and thank you very much.